Hi guys, today I'm gonna show you how to find the derivative of log function using the derivatives rules. So, so the derivative of log of any base a of x, log base a of x prime, it's 1 over x natural log of the base a. So let's do an example here. First of all, we're just gonna start with easy examples and we can move to more challenging examples. So let's find the derivative of log base 5 of x plus 1. So the base here is 5. So it's going to be 1 over whatever in here. So x plus 1 times natural log of 5. But here we have composed function, so we have to use the chain rule, but the derivative of x plus 1 is just 1. So derivative of x plus 1 using the chain rule is just 1. So just going to be 1 over ln of 5 times x plus 1. So that's the derivative of our example. So let's do another example. Well, before we go to another example, let's find out what's the derivative of natural log. So using the same rule, so derivative of natural log of x. So the base here is e. So the base is e. So the base here is e. So it's going to be 1 over x times natural log of e, which is just 1. So we end up with 1 over x. So derivative of ln of x is just 1 over x. So let's find out the derivative of f of x, which is sine of ln of x. So we will find out what's the derivative of f of x, which is f prime. So, and here we have again composed function. So we have composed function here, sine and ln. So we gotta use the chain rule. So let me remind you about the chain rule. So if f is a composed function, f of x, it's a composed function of h composed with j of x. So the chain rule, it says if you want to find the derivative of f prime, the derivative of f, which is f prime of x, just gonna be h prime applied to g of x times g prime of x. So in this case here, h is sine. So sine is h and ln of x is g. So we're gonna do sine prime applied to ln of x times ln of x prime. So let's use the chain rule. So f prime of x will be sine, the derivative of sine is cosine. Cosine applied to ln of x times the derivative of ln of x. So that's the chain rule. Combine with log rule. So cosine of ln of x and the derivative of ln of x is 1 over x. So your final answer will be cosine ln of x over x. Let's do another example just to give you an idea how to do the derivative of log using the rules. So another example, let f of x is ln of 1 over x. So we want to find f prime. So we can use the rule for to find the derivative of this, but let's simplify it a little bit using the power rule for logarithm. So remember the power rule for logarithm. So ln of a to some power n is the same thing as n ln of a. So this is called the power rule for logarithm. So let's apply it here. So 1 over x is x to negative 1. So it's going to be L of x to negative 1. And now using the power rule for logarithm, we pull the negative in front and ln of x. So minus 1 ln of x, which is just negative ln of x. So instead of finding the derivative of this, it's easy to find the derivative of this. So we know, so f prime now of x, negative 1 is just constant, and we know the derivative of ln of x is 1 over x. So that's my answer to it. So I use the power rule for logarithm to simplify my function, then apply the logarithm rule to find the derivative of that function. So let's look at another example, also using the chain rule. So suppose my f of x, it's log base 10 of x cubic plus 1. Move this up. We want to find f prime. So f prime, so using the rule, it's 1 over So using the rule, it's 1 over x cubic plus 1 times ln of 10. but we have composed function here, so we need to use the quotient rule. So the derivative of x cubic plus 1. So using the power rule for this, we get 1 over x cubic plus 1 ln of 10 times 3x squared, using the power rule for derivative. And the power rule for derivative, just a quick reminder here. So xn, derivative of xn is n times x n minus 1. So for example, if I have x to the fifth, so will be 5, and x to 5 minus 1, so we get 5x to the fourth. So that's what I apply here. So this is called the power rule for derivative. Now let's do another example, and this is again example is with the product rule. Need more space here. Okay, so let f of x equals sine of x times ln of 5x. So I have two functions here, and we want to find the derivative of their product. So again, just a quick reminder here for product rule. So f times g prime is f prime times g plus f times g prime. So in this case, this is your f sine, and ln of x is your g. So let's apply the rule. So what's the derivative of sine? So f prime of x equals the derivative of sine, or sine prime, times just the second function as is, plus the first function as is, times the derivative of the second function, using the product rule. So now let's simplify. What's the derivative of sine? I'm asking. Yes, you got it. The derivative of sine is cosine times ln of 5x plus sine of x times, so the derivative of ln of x, so we're going to use the logarithm rule combined with chain rule, because we have 5x instead of x, so it's going to be 1 over 5x times the derivative of 5x, which is 5. And now we can simplify a little bit. You see, 5 and 5 is gone, so we get ln of 5x times cosine of x plus sine over x. So that's the derivative of our function using the product rule here, logarithm rule, and chain rule. So let's do Another example, and this example is about the quotient rule with the logarithm rule. So I need to move this up. Yes, suppose my f of x is, so my f of x is ln of x divided by x squared. So you see this is a fraction, so this is about quotient rule. And just quick reminder for quotient rule, so if you have f over j, you want to find the derivative of it, so it's f prime times g minus f times g prime over g squared. So this is the quotient rule, and we will apply it here. So it's gonna be, so f prime here will be the derivative of ln of x prime times x squared minus ln of x times x squared prime, and the whole thing over x squared squared. So let's simplify. What's the derivative of ln of x? Yes, you got it. It's 1 over x times x squared minus ln of x. And what's the derivative of x squared? Thank you, you got it. Yes, is 2x. So is 2x using the, what rule you are using? Yep, you are using the product rule. So not the product rule, I mean, but the power rule. So the derivative of it is 2x. Divide by, yes, so x squared, the whole thing squared, where is it? Yes, you got it, it's x to the 4th. And now let's simplify a little bit. So we can see here x squared, just one x left over, minus 2x ln of x over x to the 4th. And now you can factor out by x. You get 1 minus 2 ln of x divided by x to the 4th. And finally you can get rid of x and the numerator and get 1 minus 2 ln of x over x to the 3rd power, and that's your answer to that function. So let's at the end just remind you with the rule for a logarithm, the derivative of logarithm. So again, log base a of x, derivative of that is just 1 over x natural log of a, and the derivative of natural log of x is just 1 over x. Now combine natural log derivative with the chain rule. If you have ln of u, and u can be a function, so the derivative of that 1 will be 1 over u times u prime. And u can be anything. So for example, if I have ln of 2x plus 1, so the derivative of this function will be 1 over 2x plus 1 times the derivative of 2x plus 1, which is just 2. So you end up with 2 over 2x plus 1. So using the chain rule and natural log rule for finding the derivative. So I hope this video will help you understand the derivatives of logarithm functions, and thank you for watching, and see you next time.